Just as a reminder, hey, a great way to check your work when you're done. Smaller angles in a triangle are always opposite smaller sides. So the smallest angle is opposite the smallest side, the largest angle is opposite the largest side, and the middlest angle is opposite the middlest side. So that'll let us check our answers for accuracy. So if you go back and you look at the one that we did in example 1, you'll see that that's true. All right, so why don't we apply the law of sines? Why don't we try a problem involving a little story? So we are told the ship is sailing due north. It is going up our page. At a certain point, the bearing of a lighthouse that is 7.6 kilometers away is north 38.4 degrees east. Later on, the captain notices that the bearing of the lighthouse has become south 33.4 degrees east. So it wants to know how far did the ship travel between the two observations of the lighthouse. So again, they didn't give us a picture, so what I'm going to do is I'm going to draw a picture. So I'm going to do my best to try to draw a little cargo ship. They're kind of big and boxy. And then we have so there's my ship, and it's going north. So my ship is going straight up. That's north. But what happens is from north, they are going to look to the east about 38.4 degrees. They're going to look to the east 38.4 degrees, and 7.6 kilometers away from the boat, they're going to see a lighthouse. So, here's let's, why don't we just go ahead and then it's going to have a little radio on top, and there's the beam, there's my lighthouse. So the boat keeps sailing east or north. It's sailing north. Well, what's going to happen is at another point, the boat is going to reach further up. And we are told from the south end of the boat, it now looks to see the lighthouse at a bearing of 33.4 degrees. And what they want us to find is how far did the boat travel? That's what they want. So if we label our triangle, we can label it A, big B, big C, because those are my angles. That would make not X, but little c, little a, and little b. So we want to find little c. And they gave me big B and little b. So what we are going to do is I'm going to use the equation sine big B over little b equals sine big C over little c. Well, there's a problem. I don't know big C. But again, I know all angles inside a triangle must add up to 180. So 38.4 plus 33.4 plus angle C has to add up to 180. So we add these two values together, and I am going to get 71.8 plus C equals 180 degrees. Subtract 71.8 from both sides, and we're going to find the measurement of angle C is 108.2. Now I know big C. So now we're ready to rock and roll. So let's find the sine of big B, 33.4. There's my big B, over the length of little b, 7.6 kilometers. That's going to equal the sine of big C, 108.2, over the length of little c. So from here, what I'm going to do is I'm going to cross multiply so I can find the length of little c. So c times the sine of 33.4 equals 7.6 times the sine of 108.2. Divide both sides by the sine of 33.4. Excuse me. And then I'm going to bang all of this into my calculator so I can figure out what it is. And it's going to come back And depending on how many places I ask you for, since we only have 17.6, that's going to be about 13 kilometers because I have two significant figures in my answer. So we're going to say 13, or if I give it another decimal place, I got 13.1 kilometers. So that's how far the ship traveled between the two bearings. All right, let's try the one underneath it. You know what? Why don't we go ahead and do that one in class? See if you can solve it before we get to class, and then I'm going to go over that one in class with everybody. So if you got questions, make sure you come in with those questions, and we'll get those answered for you. I'll see you when I see you.